Hello everyone to this tutorial about Resilient Distributed Dataset or RDD. Resilient Distributed Datasets or RDD is a fundamental data structure of Spark. An RDD in Spark is an immutable distributed collection of object sets. Each RDD is split into multiple partitions. We call them similar pattern with smaller sets, which may be computed in different nodes of the cluster. So, RDD simply is the fundamental data structure of Spark. And we should remember that RDD are immutable, so we cannot change them, but we can transform them. And that's what we are going to see when we start the practical lessons. So, each DDD is split into multiple partitions. And these partitions can be computed in different nodes. And that's what makes Spark fast in processing data, because it uses several nodes instead of one machine. RDD can contain any type of Python, Java, or Scala objects, including user-defined classes. Formally, an RDD is a read-only partitioned collection of records. As we said, RDD is immutable. Data is unchangeable, but we can transform them. RDD is a fault-tolerant collection of elements that can be operated in parallel. Because there are several copies of a certain piece of data is created or are created and distributed on several nodes. So if one of them got corrupted, we still have several copies from the same data. And we see here that the features of RDD in this graph. First, it's in-memory computation, which means a much faster way to process the data. Instead of transferring data to the hard disk and reading back the data from the hard disk, everything is processed in the memory, which make it so fast. Lazy evolution means transformation in Python Spark RDDs is lazy. That means it doesn't compute the result immediately, means that execution does not start until an action is triggered. When we call some operation in RDD for transformation, it does not execute immediately. Lazy evolution plays an important role in saving calculation overhead. The other feature here is fault tolerant. RDDs track data lineage information to reconstruct lost data automatically. If failure occurs in any partitions of RDDs, then that partition can be recomputed from the original fault-tolerant input dataset to create it. The other feature here is immutability, which means the created data can be retrieved anytime, but its value can't be changed. And partitioning means RDDs are the collection of various data items that are so huge in size, and because of its size, they cannot fit into a single node. And for this reason, it must be partitioned across various nodes. The other feature here is persistence. And persistence means an optimization technique where we can save the result of RDD evaluation. It stores the intermediate result so that we can use it further if required. And the last feature here is coarse-grained operation. The coarse-grained operation means that we can transform the whole dataset, but not individual element on the dataset. However, on the other hand, fine-grained means we can transform individual element on the dataset.